Hello, hello, and welcome back to another fantastic video with me, your host, Mr. Jans. Today we're talking about acceleration. For those of you super confused about what this is, hopefully this will clear things up for you. All right, so acceleration is simply the rate of change of the velocity, or the rate at which the velocity changes. So acceleration is the rate at which velocity changes. Now, the rate at which velocity changes. Since we're talking about velocity, that means that acceleration is going to be a vector. Now, if you still don't know what a vector is, I would suggest you pause the video right now and write down what you think a vector is before I tell you. So, I'll give you a second to pause. And we're back. A vector is something with both magnitude and direction. Magnitude and direction. And what I mean by direction is that it's either positive or negative. All right? Now, we are going to calculate acceleration with this equation right here. Acceleration is the rate at which velocity changes, which means we are going to have the change in velocity divided by the change in time. Change in velocity divided by the change in time. And I'll write that out for you. Change in velocity divided by change in time. Okay. Change in velocity, all this means is v final, or the velocity that I finish with, minus the initial velocity, or the velocity that I started with. Delta t, or change in time, is just t final minus t initial. Okay? Now, when we're talking about acceleration, acceleration has some weird units. Okay? So let's look at the units for acceleration. So units for velocity, we can use something that we've used a lot. Let's say meters per second. So if velocity is recorded in meters per second, and velocity goes on top in my acceleration equation, then I divide by seconds for time. That means I have meters of meters per second per second. Well, that doesn't make sense. It's a lot easier just to say meters per second squared. Or we have our distance divided by the time squared. Those are the units that we use. Now, if our acceleration is positive, then we have something that is speeding up. Now, if acceleration is negative, bet you can guess it, we have an object that is slowing down. The object is slowing down. All right. So let's do an example. We'll do an example or two together. And what I want you to do with these examples is write it down, work it out yourself, see if you can do it, and then watch me work through it and correct it from there. Okay? So first example. So I'm driving at 12 meters per second. And speed up to 20 meters per second in, let's say, 8 seconds. What is my acceleration? All right, so what is my acceleration? Well, first thing I want to do is I want to identify what I know. So here's what I know. My velocity that I start with is 12 meters per second. My velocity that I finish with is 20 meters per second. My time is 8 seconds. And I need to know what is my acceleration. So let's make a prediction right up front. What will the sign or the direction of my acceleration be? Positive or negative? So make a prediction to yourself right now. Is it going to be positive or negative? Okay, now let's write down what it is that we know. So my V initial is equal to 12 meters per second. My V final is equal to 20 meters per second. My time is equal to 8 seconds. And my acceleration is what I don't know. So I'm going to use the equation that we went over at the beginning. Acceleration is equal to V final minus V initial divided by the change in time. And I just plug everything in. So my V final was 20 meters per second. My V initial was 12 meters per second. And my change in time was 8 seconds. And then I just solve. So now I've got acceleration is equal to 8 meters per second divided by 8 seconds. And my acceleration is equal to 1 meter per second squared. And it makes sense that it's positive because it said that I was speeding up. Speeding up, if my acceleration is positive, the object is speeding up. So we got that one good. Okay. All right, let's do one more example. So I accelerate at 10 meters per second squared for, let's say, 5 seconds. And